And this is not just about carbon and accountability. It's about everything in life. If you want to improve something in life, you first have to measure it, and you first have to try to understand it, and then you can try to improve it or reduce it as you wish.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams.
Hello, everyone, and welcome to the Week in Green Software, the show from the Green Software Foundation that brings you the latest in green software news. I'm your host today for this week. My name is Carlos Pignataro. And this week, we have a super exciting set of topics, papers that we're going to be covering. And more importantly, we're joined by an outstanding speaker. This week, we're going to actually dig into green AI from a number of different angles. How to manage AI using green in practice, how to measure, how to benchmark, how to govern, and how it all connects to compliance and real-world incentives, data that chief sustainability officers and others can actually use, with the board or in different contexts. We're also going to talk about infrastructure, market forces showing up around the demand of AI. And we're going to do that, as always, by describing a number of papers, a number of videos, invite you to actually look at them and do a little bit of dissection of what we think. So today, I'm joined by Aditya Manglik. And Adi, for those who don't know you, would you please introduce yourself?
Carlos, it's great to be here, and thanks a ton for the wonderful introduction. I'm super excited to be here, as always. And let's take a look at these papers that discuss how we can engineer prompts to be more green. There's a bit of a discussion about the SCI standard, and also a very exciting YouTube video which came out, which tells that because of the enormous demand for memory, hardware prices are going so up that they cannot use the rest of the laptops. It's crazy. I'm pretty excited about this episode, and let's get started.
Thank you, Adi. I am equally excited, and actually your excitement is contagious. Your knowledge is a wealth that I appreciate you sharing. For those who don't know me, I'm Carlos Pignataro. I'm the founder and principal for Bluefern Consulting. And a final reminder, Adi, extended an invitation for all of you to actually read the papers and watch and look at the video, listen to the video that we have. Every single piece of citation and mention is going to be linked in the show notes right below. So, Adi, if you're ready, let's get to it.
That's perfect. And once again, we talk about this in every episode, and I think it's always good to mention again, as our dear listeners, if you have any news or if you have any video that you want to discuss or you want us to dissect, we would be very happy. Please reach out to us and let us know what you want to hear about. With that done, let's talk about the first discussion point for today. The SCI standard, and we have an article which describes how we can provide the software emissions data that CSRD needs. For our listeners who are not familiar with CSRD, CSRD is Corporate Sustainability Reporting Directive by the European Union, and it is the new directive that asks companies to report their carbon intensity and sustainability data. It's very interesting, it's very important, and this article connects the software carbon intensity standard from Green Software Foundation exactly to what companies need for CSRD reporting. The article tries to lay out a path from software energy data to a number that you can defend in an audit. And that is wonderful because compliance and audit is a great way to get started with reporting these numbers. The big point is that compliance is pushing sustainability measurement from nice to have into a must be explainable. And that's where the change happens. That's where the mindset shifts, because when we start thinking about how we explain these numbers, then we can also start to reduce them, to optimize them, and that's the end goal.
I love this, Adi, because, first of all, thank you for expanding the acronyms, and to me, the beauty of this is that within this first article, we have two very diverse ecosystems that speak different languages, that have different personas, and they're actually intersecting. We have the geeks on one side defining standards, and we have the software carbon intensity as a SCI as a standard from the Green Software Foundation, and we have CSRD, which is a compliance element, and
legal.
Exactly. And, it's interesting because you're talking about a number of qualities which, we're actually bridging from a technical realm into compliance, legal. You talked about traceability, explainability, all of that, right? So I love this topic. I would encourage all of our listeners to not only scan through, but actually, dive a little bit deeper on this paper, because it actually connects these two realms, make things very real, and, bridges the conversation between a CTO or a head of technology and data with a CSO and what needs to be reported.
Exactly. And that's I think the hardest part, right? Communicating between, for example, the CTO and the engineers is hard. And that's exactly the problem that we're trying to solve, right? So the article asks, Carlos would be the perfect person to talk about this, given his enormous experience. But if you were to advise a team that is considering CSRD readiness, or if you were to just talk to a company that's looking into getting these numbers, what is the SCI-related capability that you would prioritize? What would you love to dive into? Measurement, data quality, governance, ownership, talking to CTO, talking to CEO, or maybe even talking to the engineers directly?
Oh my gosh, Adi, thank you for the questions. Thank you for the framing. At this point, Adi, I'm sitting on a chair, and this chair has actually four stools or four legs. It's a four-legged stool. It's a four-legged chair. And I was thinking, what might happen if I actually remove one of the legs? If I actually do that, the whole system comes into imbalance. And this is why, both you and I were, every time, do you prioritize oxygen or water? Well, that's a false dichotomy because I want to have both.
Yes, I want both. Yes, exactly. Yeah.
So,
100%.
but at the same time, I feel different areas to prioritize are actually, they have a different sequentiality potentially, and that's something that we can talk about in addition to prioritization. And by the way, prepare, because I'm gonna bounce the question back to you to see what you think. But I feel, Adi, I feel that we can start measuring and explore our data and assign ownership, but unless we have a solid governance framework before all of that, we're not going to have traceability. We're not going to have appropriate ownership. We're not going to have accountability, responsibility, informability, etc. Right? So I feel, even though all these things are needed, there is a sequentiality on which we need to start with governance. Part of that governance, includes what we were talking about. What is the ownership of getting the measurement? It's not the CSO.
That's the most
what is the
important part.
ownership?
Yes.
Yeah, what is the ownership of actually, translating that
Finding the
and
ownership is the
reviewing
first
into
step.
units,
I completely agree. Yes. Yeah.
right? And, I also feel, Adi, that, data quality is one of those musts that no matter what we're going to be talking about, we can actually put it as a wild card. Is going to be necessary, no matter what. But I would feel, and perhaps not today, I would feel data quality in itself is too big of a descriptor. Is like goodness. I want to have motherhood. I think, there's a way
It's an
of
umbrella term.
expanding.
Yes. Yes.
Is a meta term which is composed of
You're
a
100%
number
right,
of
Carlos. Yeah.
and I feel an invitation to our listeners, or readers or listeners, if you have as many people we know within our circles are a champion of data and care about data, and you have a great paper or article that you want to point us to or that you want us to discuss, share it. And with that, Adi, how would you prioritize measuring, scaling, coverage, quality, governance, etc.?
Yeah, so this is I think you completely had beautifully described it as a chair example. I love the chair example, but I am a biased person, okay? I'm very biased. I come from a scientific background and now I work in engineering. I am an engineer at heart, and because I'm an engineer, for me, measurement, coverage, and accuracy is a priority. I'm not saying other tools in the chair are not important. They are important, but I would take ownership of the measurement. I always like to say that you cannot improve what you cannot measure. And this is not just about carbon and accountability. It's about everything in life. If you want to improve something in life, you first have to measure it and you first have to try to understand it. And then you can try to improve it or reduce it as you wish. But accurate measurement remains a big problem in almost all computing systems. For example, we don't even understand the embodied emissions associated with DRAM, the embodied emissions associated with hard disk drives or with SSD. We simply do not know. We simply don't have the numbers. And as a scientist, as a researcher, as an engineer at heart, I think I would love to know them, and I would push, if there's anyone out there who knows it, these reports are a great first step in the right direction. But that said, one person takes ownership of measurement does not mean that everything else gets deprioritized. We also take care of data quality. As Carlos said, it's a very loaded term like motherhood, but it's important. We need to make sure the numbers are correct. We need to make sure the numbers line up and they make sense. I remember one time I was taking measurements of a system like a processor using those standard tools to measure the power of a processor. And I remember seeing a value of that this processor is using 65,000 watts. I was like, what are you talking about? 65,000 watts? No, come on. So this is a stupid example, but you see how quickly data quality can become an issue, right? And these numbers can easily slip through. You would not even realize that the number is in your data set. So yeah.
There is clearly a subject matter expert that needs to be in the loop, doing reality check with the data.
Yes.
And as a scientist, I'm gonna present you with another false dichotomy. Adi,
Please.
would you rather have great precision in a small context of measures, or a scale coverage with less precision?
Oh my God, that's an impossible question to answer. First of all, I love the question, and second, I refuse to answer it because it's gonna kill me. And so I want both. I want precision and I want accuracy. Okay, it's all.
But I think that's a great answer, because I feel you're onto something important, which is every time we optimize for one of the binary endpoints,
we lose the other.
We completely lose the other, and the maxima for the system is
somewhere in the middle.
Somewhere in the middle. Exactly.
You're exactly right, Carlos.
Which is what you're saying, right? So, oh my gosh, I love this conversation.
Yes.
Adi, I think we can move on to our second topic today, which with something that more and more people do more often when we see. I was reading the MIT report on State of AI 2026 the other day, and things like the overall deployment of AI has been faster than the internet and faster than right. So it's a very it's not a niche question anymore when we talk about LLM energy use.
Yes, it's not a niche question for this podcast at all.
Exactly. So it's not an obscure corner question. Everyone is exposed to this in most days. And we have a very interesting paper as well, a research that actually argues that prompt energy impact is not mostly about count of characters or length of a prompt, but it's actually about the semantics and the meaning and the specific keywords that actually steer the inference on the model, which is actually what determine the path and the cost.
Yep.
In other words, we can have two prompts of similar length.
Yes.
But depending on the semantics, they have completely different energy footprint as they do inference of different meaning.
Yes.
In a way. So we're trying to demystify, are shorter prompts greener? Are are more intentional, deliberate, and focused prompts greener. So
Yeah.
green prompting,
Yes.
what say you?
It's a beautiful paper. I was a bit surprised when I first saw the paper, but when you think deeply about it, it makes complete sense. The paper argues that it's not about character or it's not about the token count. It's about the specific task that the model is doing. And that is beautiful because the attention mechanism switches the path that the model takes based on the semantics, right? So thinking deeply, it makes complete sense, but on the surface, it's not directly apparent. That's why I really love the paper, because essentially they're saying that changing some words in your prompt can reduce the energy cost by up to 50%. That is enormous. One thing I was curious about is, does this also affect the task performance? When I say task performance, it means the accuracy of the output, or does it affect, if I change the words, my output will change, right? Does the output become more useful or does it become less useful? I don't know. And I would love to know, how is the energy correlated with the usefulness or the accuracy of the output? But apart from that, it was a great paper. It also reminds me of this very interesting area of research in computer architecture called as approximate computing. In approximate computing, what you do is that you reduce the precision of your outputs to approximately calculate the value. So instead of calculating 2.545, you calculate 2.5 into 2.5, which is very close to the output, but still, it's not accurate, but it gets the job done. What do you think about this, Carlos? That's really fascinating.
I think we do it just by our nature, because I don't know any
Yes,
calculator that does
exactly.
pi or
That is
e.
human. This is human, yes.
Right? I think putting the intentionality on it, on which, to me, the important part is knowing the precision that I'm much bound the precision on the output based on how much I chop on the input, right?
Yes.
So
Yes,
that's number
exactly.
one.
Yep.
And the second thing that this makes me think, which Adi, I think is relevant to this paper as well, is how much from a product perspective, I'm gonna do my product management,
Yes.
should this be put on the user, or should this be an infrastructure design consideration?
That's a great question. That's a very great, I did not think of this. I would love to know. What do you think?
Oh, I mean, to me, it's I really, have this thing of the more that we can actually not depend on
The
a
user?
user, the better. I would actually, so for example, for green prompting, right?
Yeah.
So going back to, or for intentionally truncated input, right? Same thing.
Yes.
I feel um, there is a feature at the infrastructure level
Yep.
that actually can optimize one for everyone, and not actually depend on, especially because, like, I don't know the statistic, but I imagine that every task that we do requires a plurality, a multitude of prompts.
Yes. Exactly.
If we actually look at the overall
Design.
conversation,
Space. Yeah,
and
exactly.
we can actually optimize infrastructure wise, because a lot of it is guided, right? The
Yes.
responses are guiding the next
Yes.
question.
Yes.
I feel there's a role for infrastructure to actually optimize,
Yes.
at the guidance level.
I think that's a very strong point. And at the infrastructure level is where the maximum improvements will come from, because the infrastructure understands the hardware. Infrastructure can talk to the hardware and they can actually directly reduce the power, or they can see the energy improvements much closely. And these are really great points. Thanks a ton for mentioning the difference between putting it on the user versus putting it on the infrastructure. I did not think of that. One more point that I wanted to add was that I think some people are not aware of it, or maybe most people are, but I always love to repeat it. When we do a conversation with an LLM, for example, we're sending multiple prompts in the same window. What very often happens is that all of your past history, all the prompts that you sent in the past, most of them are repeated with your future prompts. So that's how the context is built up over time. And essentially, you are burning a lot more energy for prompts that are deeper in the conversation as compared to prompts that are higher up in the chain, or let's say earlier in the process. That is also one place where users can look into reducing the energy consumption, because if you keep building up on tasks, you are essentially sending longer and longer prompts for the simple task. One place where I think,
100%,
yeah,
and particularly when the last prompt is just,
thank you.
a really quick yes,
It's just a thank you.
if it is a thank you, or if it is a, just a very, very incremental,
Yes,
small addition.
yes, exactly. That's a great point. I really love this point. Thanks a ton for mentioning it. I want to move on to the next topic, which is super close related. These guys call it an LLM energy lab, in which they try to benchmark energy and emissions across models and hardware. The link will be included in the description, but what this project is basically about, it's about a web app and an API for benchmarking and comparing LLM energy across cloud and bare metal. The useful stuff here is the push towards comparable measurement, not just getting a number, or not just, oh, my run costs X in this specific condition, in this specific hardware, but rather, how does this model, how does this setup, how does this workload compare to alternatives? How do I make a fair apples to apples comparison, right? And if this kind of benchmark becomes common, it could really influence procurement, model selection, even the default settings. It's really useful, and I think having a fair comparison is also the first step in improving things. What do you think about this, Carlos?
Wow, this is awesome. And Adi, the first thing that I think is that I have a very strong appreciation of the diversity of resources that we're bringing to our audience today, because we have specifications and standards, right, for interoperability and for scale. We have papers. Now we actually have running code. The actual pointer is actual is to a GitHub repository.
Yep.
So I feel first of all, Adi, is important to up level what this is doing, because when we're talking about benchmarking,
Yep.
the first thing that comes to mind is trustworthiness of that benchmarking.
Exactly.
And how much we can actually trust to drive. You mentioned it beautifully before. We don't measure just to have numbers stored on some database, or we measure to ultimately drive decisions.
Yes. And decisions have to be comparable.
Exactly. So we need transparency. The challenge of, I want to share that as something that I have done in a couple of previous slides. The challenge of actually transparency and comparability about not only hardware between hardware, but hardware and cloud. Yep. is completely non-trivial because of the systemic elements that come to play, right?
Yeah, 100%.
I feel we need is something that is completely needed, and I would take, given that this is running code, I would take a early release often approach, in which I expect this is going to continue improving, because it really is a non-trivial. But those are, many times the solving those is what actually move the amperometer, move the needle.
Move the barometer, yes, exactly. Yeah.
So what is really a standardized workflow? What is really comparing different computer architectures?
Yep.
And again, I'm gonna go back to something that you shared earlier, which is we're not even talking about embedded carbon here. This is runtime, right?
No, this is the runtime. Exactly.
This is completely runtime, and it's something that, if you don't mind, Daddy, let me make a small parenthetical, because it's something that I feel paralyzes many green software practitioners.
Yes, please.
Thank you. It is so easy to start compounding, a problem to be solved to the point that we become overwhelmed.
Yes.
And we're, under a mountain of indirections, because we keep adding and adding. And, this is why a systemic approach, what is our system, define our boundary, what are we measuring with, what precision is so critically important. I know
It's very
someone
important.
else
Yes.
is going to solve another module of the system,
Yep.
and we can orchestrate at some point. But I would encourage us, to not get self-overwhelmed by conflating different parts of this, right? So we understand the scope of
Yes.
The LLM Energy Lab, right? Is runtime, but it is compute on bare metal as well as cloud. What do you think, from a researcher perspective, from having done both, cloud and bare metal? Again, I'm not asking you to prioritize, because it is again a not only an impossible task, but a false dichotomy. But what about standardized workloads? Useful, not useful?
Yes. So first of all, I really appreciate the example you shared. I love these examples. There's a huge difference between doing the things for cloud versus for metal, because in cloud, we simply don't have access to the hardware performance counters, which give us the data that we need. With that said, I would also acknowledge the efforts of cloud service providers who do provide these kind of emission reports into the system. I've seen those reports. The numbers are there. If the numbers are exactly what they say they are, that's a different matter altogether, but the numbers are there. With that said, on metal, you have complete freedom. If you have hardware that you own, I would strongly recommend profiling the hardware yourself. And regardless of the cloud or the metal, as you said, it's a false dichotomy. What's important is trust. What's important is our ability to believe in what we're seeing. And that comes from standardization. And I think this is where this lab provides a beautiful idea. It provides a beautiful example that all three are important: standardized workload, transparency about the hardware, and independent verification. Standardization of the workload allows a fair comparison because the workload is the primary task, right? Being transparent about the hardware is also very important because it allows you to measure accurately and precisely. It knows, it tells if you know what you're doing. And third is allowing independent verification, which is critical for supporting reproducibility and increasing the trust in the numbers. Trust is what allows the field to progress together collectively. And I think trust is what we need most of all in today's world, because there's a lot of greenwashing out there. There's a lot of fudging out there. But let's not go there, okay? This is not a rant. I think it's important that all of us agree on how we're going to drive the field forward. And once we agree to it, we stick to it. And this is a pretty good step in that direction and seems to check all the right boxes. I don't know, what do you think about that?
Yeah, it's the additional thought, I think, you covered this beautifully. I would go back to something else that you implied before as well, which is, in addition to, always continue as, researcher scientists to get both accuracy as well as,
Yes.
boundary on that.
Yes.
But
Yes.
we need to do that undoubtedly. And this is a particular case on which, a little bit of reality check,
Yes.
goes a long way as well. Do these numbers, I'm actually going to be, doing comparisons that need to be done.
Yes. Yeah.
And at the same time, there is levels of indirection as well as a trust element.
Yes.
We don't access the hardware, we don't access the registers, we don't access the energy bill. We don't access anything. Everything is, we have virtualization of different layers.
Yes. Multiple layers, exactly right.
Multiple layers, none of which knows the
other-
outside
yes.
container.
Yes.
So there is a technology trust element.
Yeah.
do these results make sense? Or like you say, am I in 47,000 watts on this flashlight?
Yes.
Or am I spending, 3 milliwatts to, do this large workload, right? So
Yeah.
that is often underestimated. Sometimes we
Yes.
get so deep into the numbers and
Yes.
the deviations and, a polynomial, approximation to the curve that we actually don't check. Wait, am I going north or south? Is this
Exactly right.
right?
Exactly right. We miss the forest for the trees.
Right, right.
All the time. Yes.
So, putting a, virtual pause for a second, abstracting yourself, looking out, looking up, looking to the side, chatting together, bringing, eyeballs that have not
Yes.
been looking at this for forever. That's where collaboration adds value.
Exactly. 100%. Bringing in new eyeballs to get better collaboration. I completely agree with that. Yeah.
Right. So, listen, I think, Adi, we're getting close to our fourth and last topic.
Yes,
You
sir.
told a little bit about this at the beginning, talking about laptops. So, what is
Yes,
this fourth
sir.
topic about?
Oh, it's a beautiful video. So, by the way, the video link will be down below. But we just saw a video which reports that secondhand laptop market is seeing a shakedown. Secondhand hardware market is seeing enormous impact of RAM and memory prices. Suppliers are now stripping RAM and hard disk drives to sell them separately because the separate disks and the memory chips are worth more than the entire laptop themselves. It's a great example of second order effects. RAM prices increase, people charge all possible systems for RAM. This increases hardware cost, and this drives total device turnover. Essentially, we're seeing a lot more devices end up in the landfill simply because we don't have the memory and the hard disk to run them. And because they are fundamental components, we end up discarding these devices because it's worth more to sell the memory. We can't blame these suppliers, right? This is what any business would do, that they would strip the parts for maximum profitability. But it really hurts the end consumer because there are people out there, hobbyists, small companies, people who enjoy working with computers for the fun of it. You could buy a $50 discarded PC a few years ago, and it would be with great specs. But today, that's not possible anymore. I'm very curious, Carlos. What do you think? How should sustainability teams respond when AI readiness requirements start quietly increasing hardware baselines and they start shrinking the reuse options?
This is such a thought-provoking article, and Adi, your description of it was so visual, vivid, and relatable. It's something that all of us can relate to it. And a few things, come immediately to mind. The first one is that when we're talking about this tool, what's being prioritized is the dollar, euro, yen,
Yes,
or financial and
exactly.
not economic, financial rather, variable
Yep.
within the decision tree,
Yep.
and the first thing that I was actually thinking, and what would be the most important elements to reuse from a rare earth metals perspective.
Yes, that's a very important question. Rare
What
earth
would
metals are
be
super important now. Yes.
right, and
Yeah.
what would be the most important things to reuse based on you know human labor in the supply chain
Yes.
perspective.
Exactly.
Which is why I think the more than that we can actually have frameworks
Yep.
that account for PPP,
Yes. Yes.
planet,
Exactly.
people as well as profit, and do that in a standardized way throughout the supply chain, the more that we're going to understand the impacts of this, right? And that's something that needs to exist, beforehand. I did add a lot of standardization in my career of protocols, architectures, and
Yes.
often I share that the driver is interoperability.
Yep.
And I feel, we're actually expanding the definition of standards, and, they're not only used to interoperate, but frankly, these are, pen company and cross organizational decision-making criteria that these standards actually allow us to be able to do across time and space, across a supply chain that starts in a continent and starts in a particular time, and is the only way in which we can actually, correlate, end-to-end the system, not necessarily cradle to grave, but getting close to it, right? So
Yes, exactly. I completely agree. It's a pan company decision, and that's how it is to be done. Yes.
right. The other thing that, this immediately made me think about was that there's many R's, letter R, verbs that start with the letter R,
Yes.
that we can actually, leverage, within our life, and they have different levels of return. And, we talked about reuse,
Yes.
which is not fully what's happening here, but there's a little bit of reuse, but then there's reuse, repurpose, blah, 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 recycle.
Yes.
And the fact that,
Exactly.
some of the, I'm not making up a number, but, 95% just, in weight of a system like a laptop can actually get into a much less efficient environmental cycle, such as get recycle as opposed to get reuse or repurpose.
Yes.
That is something that needs to be evaluated, as long as with the profit benefit of scavenging, if I can use that verb, RAM from a device.
Yes, I agree 100%. And it's very important to always keep the 4 Rs in mind: reduce, recycle, repurpose, and reuse. With that said, this was a fantastic conversation, Carlos. Thanks a ton. Let's dive into the events.
Thank you, Adi. It's always, I feel that this is one in which, it's not only bi-directional, and we're, learning from each other and sharing perspectives, but also is a multi-point value.
Yes,
That
exactly.
gets exponentially with our listeners.
Exactly.
And the more that we can actually close the loop with them,
Yes,
the better.
I completely
So-
agree 100%. It's really valuable to have different perspectives. That is exactly what's needed.
Events, as you mentioned. So let's do a quick look at the upcoming events and trainings. We're only calling out the ones that actually happen after March 26th of 2026 of the current year. So first up, we have the Sustainable AI Climate Tech Founders, April 22nd at 1 p.m. Pacific Daylight Savings Time in San Francisco. We're going to include the link down below. Next up, Sustainable AI in April 23rd at 6 p.m. Central European Standard Time, Utrecht, and we're also going to include the meetup link up. So, listeners, readers, that's it for today. That's it for this week's episode of the Week in Green Software. We covered quite a few topics. We went from SCI to AI to RAM. And at this point, I don't need to expand any of those because you're all very versatile and familiar with what they mean, what green prompting really means, and what is the weighting of, the relationship between energy use and the syntax and semantics of specific prompts, how to benchmark LLM in order to shape decisions. So a final reminder, we said this a few times, all the resources for this episode and for this show are in the description right below. You can visit podcast.greensoftware.foundation, podcast.greensoftware.foundation to listen to more episodes of Environment Variables. Thank you so much for listening. Aditya, thank you so much for sharing your insights. Thank you for
Thanks a ton,
joining.
Carlos. It's always great to see you, and I really enjoyed this episode. I think that paper about reducing the energy of LLMs by changing the words was fascinating. And these are the kind of ideas that I come to this podcast for. That's the ideas that we listen here, that we're here for. So thanks a lot for sharing these.
Absolutely, we all go with homework because I'm gonna, be doing additional digging and diving into these papers and adjacent places because, hopefully we generated questions within our audience, which in turn generate additional research and, we elevate the tide. So we will see you next week. It's bye for now, and thank you so much.
Thank you very much, and take care of yourself. Have a great week. Bye.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.